couple of slides from last week, and then we start a new chapter. So I was talking about the qualitative and quantitative observation, qualitative and quantitative, right? Quantitative. So I put one homework to this one, quantitative. So this is just a statement. So if you are looking 10 degrees centigrade, the temperature of water is 10 degrees centigrade. So you have a number, you have the unit. Degree centigrade is unit, 10 is number, right? So if you look something like that, that is a quantitative observation, yeah? So 140 ml water, 140 milliliter of water. 140 is number, milliliter is unit. So you are looking the number and unit, quantitative observation, right? So 4 gram per ml. So this is the density. So this is the unit, this is the number, this is the unit. So if you see something like that, that's a quantitative observation. So I put the homework, yeah? So how about the qualitative? So the water, the solution looks yellow. Yellow, Y-E-L-L-O-W, yellow, right? So this is a qualitative, yeah? And then here is a liquid. This is a liquid. So there is no number. We are just looking, and it is a liquid. That's also a qualitative, yeah? And this is solid. So this is, there is no number and unit involved. So this is also qualitative. So there is a homework problem, yeah? So yeah, homework problems are important for the exam, yeah? So I put about 10 to 15 problem in homework. So they cover pretty much everything what I am teaching. So those will be in the exam. Not exactly the same homework problem, but if you understand the homework problem, you can easily solve the exam problem. Yeah. So another one is thermal energy in different states. Thermal energy in different states. Energy in different states. Different states. Different states means solid, liquid, and gas. So solid, liquid, and gas. So thermal energy meaning that if the everything is made up of particles. So although you look, this is a duster, right? So this duster is made up of tiny particle inside, right? And then if you look water here, so this is made up of tiny particle here. If you look the gas in the balloon, this is also made up of tiny particles, right? So they are continuously moving all the time. They are moving, and that movement gives the some kind of the energy, and that is called thermal energy. Make sense? So if something is moving fast, that has a higher thermal energy. If some molecules or some atoms, some particles are moving slowly, they have a less thermal energy. So this is the solid. So the material are the particle are tightly bound to each other. So you will do this kind of thing in the second. If you are taking the Chem 106, the second experiment where you do the simulation is about the thermal energy. So in the solid, the particles are tightly bound like this. So they have a very small thermal energy. But in liquid, the particles are free to move, so they're continuously moving very fast. So this is they have higher thermal energy. Yeah, and in the gas, these particles are even moving very fast. So highest thermal energy here, right? In case of the gas, the particles are far away from each other, so they are moving very fast. Yeah. So this is the highest thermal energy in gas. Highest thermal energy. Highest thermal energy. This energy, and this has a kind of the middle, and this is the lowest thermal energy. So solid has lowest thermal energy. Liquid has kind of the middle amount of thermal energy between the solid and gas, and the gas particle has the highest thermal energy. Yeah, make sense? So what is the thermal energy? All the material are made up of particles, and these particles are continuously moving. So even though this is a cable, and you think that nothing is moving here, but since these are made up of the particles, and these particles are moving there, but we cannot see. Make sense? So at what temperature all the particles stopped moving? So at minus 273 degrees centigrade. If you reach this temperature, minus 273 degrees centigrade, everything stops moving. So if you put this table inside a fridge that has a minus 273 degrees centigrade, at that point, all the particles stop moving. Otherwise, particles are moving in every kind of thing. Make sense? So even if we go to the outside and there is ice and the snow doesn't have a minus 273 degrees centigrade. Maybe there is minus 20 degrees centigrade or maybe minus 10 degrees centigrade. Those particles are continuously moving there. But the movement is very, very slow in the ice. Yeah? Good. Now, so I'm talking about the thermal energy. Thermal energy lowest in solid. So these are solid. This is liquid, kind of higher thermal energy in liquid than in solid, and the highest thermal energy in the gas. Yeah. So thermal energy is dependent on temperature. So we will discuss this in detail in chapter 5. So we just want to give a little bit here. So temperature, effect of temperature. Effect of temperature, T-E-M-P-E-R-A-T-U-R-E. Effect of temperature in thermal energy. All right. So what is the effect of temperature in thermal energy? Right. So let's say I have a water here. So this is water, and this is a 10 degrees centigrade. 10 degrees centigrade. Now I heat the same amount of water here, and I have let's say 40 degrees centigrade. 40 degrees centigrade. So which has a higher thermal energy? So their molecules are moving a little slowly. They are moving 10 degrees centigrade. But if I heat it, I put it in oven and heat it. It's heated, and then the molecules start to move with more velocity. So they have the velocity increases. So if you increase the temperature, thermal energy becomes higher. Make sense? So keep increasing the temperature, thermal energy becomes even more. So at 100 degrees centigrade, it looks like more moving. Yeah. So keep heating further, and then if they go to the gaseous state and higher temperature, they have even more thermal energy. Yeah. So when we heat something, thermal energy goes up. Yeah. If the temperature is increased, thermal energy is increased. So I might put a problem like, okay, so this is a water, so this is a thermometer. So 1, 2, 3, 4, 10. So 10 degrees centigrade is fine. So here is another thermometer, and 10, 20, 30, 40 degrees centigrade here. So this has higher or this has higher thermal energy. Definitely this has higher thermal energy. So there are a lot of problems like this at the end of the chapter 1. Yeah. So higher the temperature, higher is the thermal energy. If the liquid is solid has the lowest, liquid has the highest, gas has the even higher. Yeah. So like that. So thermal energy concept. Now, so I already wrote here, so you can read those. So now so maybe a couple of problems in physical and chemical change. So there are some problems like that. So we will see. So physical and chemical change. So here is a wood. So this is a wood. So wood is basically kind of the glucose or the sugar molecule. Wood is made up of like the sugar molecule, yeah. So they call the cellulose or whatever. But at the end, if we digest this one, it converts to the glucose, yeah. So it's a kind of it's not exactly this one, but this is like a C6H12O6. So if you analyze the material here, so maybe there are 6 in this all everywhere in this wood. You will see something like this. This is a glucose molecule. Yeah, C6H12O6 is a glucose molecule, and it is made something like this. Now, if you burn it, burn it, everything is this glucose molecule is changed into the coal, right? So it's completely new material is formed. So if you burn the wood is completely converted into the carbon, the coal. Yeah, so coal is just the carbon. If you look at the periodic table, there is in one group there is a C, carbon. Yeah. So this kind of change is the chemical change. You cannot convert carbon into wood, right? You cannot convert coal into wood. Impossible. So this kind of the change is called a chemical change. So if you want to write something like this, chemical change. Now, let's say you have a hydrogen here, you have oxygen here. I already told you in the previous class. So this is hydrogen, this is oxygen. This is very good for breathing, this bonds, right? But if you bond these two together, you give a water. This neither bonds, but it extinguishes the fire, right? Water. So this is kind of the chemical change. And I told you, everything we study in this class is a chemical change. We don't study the physical change, yeah? But what is kind of the physical change? Physical change is like this. So this is a chemical change. So physical change is like you have water here, you have water, you put in freeze and it becomes ice, and you heat this ice and then it becomes water again, it becomes water again. If you heat further this water, it goes to water vapor, it becomes the water vapor, right? This is not a new substance. Water vapor is also H2O water. This liquid water is also H2O liquid water. This is ice. Ice is also H2O, and this is water. So everything is same. H2O, ice is also H2O. This water is H2O. This vapor is also H2O. Now cool the vapor, it becomes liquid water. Cool the liquid water, it becomes ice, right? So this kind of change is called the physical change. And physical change, no new substance is formed. If you do the chemical analysis, it's still the same, H2O, H2O, H2O. But if you do the chemical analysis of wood, it is 6H12O6, right? But if you burn it, it gives the coal. And if you do the chemical analysis, that is just the carbon, right? So in chemical change, completely new substance is formed. In physical change, when you look with the eyes, it looks different. But if you do the chemical analysis, still the same. Make sense? Good. So now we start the chapter 2. So you expect some kind of the problem in next homework. So which one is a physical change? Which one is a chemical change? Which is has a higher thermal energy, 10 degrees centigrade water or 25 degrees centigrade water? So something like that I will put in next homework. Yeah. Good. So for whether it is a chemical change or not, we need to do the chemical analysis with the laboratory thing. But just to look the physical, whether it is a physical changes or not, we just can see with the eyes. Yeah. Good. Now, second chapter. So this is a very important chapter. Atoms. So all this class we will be talking about the atoms. So what is the atom? What are the atoms? So you look the periodic table. I told you in the last class. Look the periodic table. What is there in that periodic table? They are called elements, right? So something that is not there in the periodic table is not the element. Yeah. Look the sodium, lithium. So let's take the first element. So this is the hydrogen. Hydrogen is the simplest element. Yeah. And then that element is helium. So hydrogen, helium. The third element is lithium, and then another is beryllium, another is boron. So you can look this kind of the element in the periodic table. Yeah. So take some hydrogen. Take some hydrogen here, hydrogen gas, and start breaking it. Keep breaking, and you will reach finally a smallest particle, and further you cannot break it. So that particle is called the atom. Make sense? So take a piece of iron. So this is a piece of iron. So this is a piece of iron. Now start to cut into two parts. So it becomes two. You cut this into two parts, and then cut further this one. Now this becomes like this, right? And then keep cutting. So keep cut. Keep cutting. Make tiny pieces, and finally you will reach the smallest particle. After that, you cannot cut that into other small part. Make sense? So that's tiniest part is called the atom. So atom is the smallest part of the element. Element means this thing. Now you are taking a piece and started to cut into tiny pieces. And when you reach the smallest part of that element, that is called the atom. So that's how we define the atom. So atom is the smallest particle of an element. Yeah. Good. And then you look the characteristics of the big tongue. So look the characteristics of this one. This is iron. I'm talking Fe. Fe is the iron. So study the characteristics of this iron, and you have set of property, right? It conducts the electricity. It looks like black or whatever, those kind of thing, right? And then take the tiniest part of this one, that is an atom. So this element, this has the same property as this one. Yeah. So an atom has the same property of the whole element. Yeah. So it is the tiniest part of the element that has all the properties of that element. Make sense? Good. So that's how we define the atom. Yeah. Good. Now, how does the atom look like? So this is the biggest question. Actually, nobody knows how the atom look like, right? But there are some models. So they think that these atoms looks like this. Yeah. So nobody knows what exactly atom looks like, but they give the model. They think that okay, this model represents the atom. Yeah. So how does the atom look like? So there is the second slide. I draw a picture there. So atom look like this. So at the center there is a very dense, heavy part. This is the center, just like this is a room, and there is a center of this room, right? So there is a center of the room. So they call this center as a nucleus. Nucleus. So this is the center, yeah. So atom has a center that is called the nucleus. And what is in the nucleus? In this nucleus, there are some tiny particles. They call protons and neutrons. So these are protons, and this one, these are protons. These two are protons, and these two are neutrons. So neutrons. So what is this one? This is the nucleus, right? This is the nucleus. This is the center of the atom. And then what is in that nucleus? In that nucleus, there are some protons and there are some neutrons. Yeah? And outside this nucleus, there are some certain orbits, like the spaces, like the space. Yeah? It's like a string, the spaces. So this is the orbit. So this is one orbit, this is another orbit, this is another orbit, like this. And in this orbit, electrons are revolving. Just like the moon is rotating around the earth, the electron is rotating around the nucleus. Yeah. So if you look at our solar system, what is here? So this is the sun here. This is the sun here, and so let's consider this as a nucleus, right? This is the sun, and outside the sun there is a Mercury. There is a one planet called Mercury, right? And then there is another planet. I don't know what is that one, and there is another planet, and in the third orbit there is Earth here. So there is Earth here, exactly like this. Yeah. So this is a nucleus. Sun is a nucleus. This is a Mercury. This is the one planet. This is orbiting around the sun. This is another planet orbiting around the sun. This is another planet, Earth. It's orbiting around the sun. So it's kind of, here is a exactly like this solar system. So at this nucleus here, what we have is atom, some protons and some neutrons. And outside those nucleus, there are many orbits, and in those orbits, electrons are revolving. This is electron. So this is electron. So there are electrons like this. These electrons are moving like this. Like this. Make sense? So this is the best known model of the atom. Is that exactly, people know what exactly the atom look like? I don't think anybody know what exactly atom look like, but they give the model, and this is the best model of the atom. Make sense? So this is the atom. The atom has the nucleus at the center. The nucleus has neutrons and protons, and around this nucleus there are many orbits. They call also electron cloud. Either they call the orbits or the electron cloud. In those orbits, electrons are moving around. Yeah. And if you see here, how many orbits are possible here? 1, 2, 3. I just write it. There are infinite number of orbits. Yeah. These are just the places. Yeah. And that's how the atom looks like. This is the structure of the atom. Make sense? So it's very important. Now, so what big picture looks like in the universe, our tiniest particle of the material also looks like exactly the kind of the mirror image. Yeah. So how big is so if you have to compare now let's talk about the charge, C-H-A-R-G-E, charges on. So charge is on this particle. So this is an atom. So this is the atom, right? I just the atom. Now this electron, the neutron and proton are called subatomic particles, meaning that there are particles inside the atom. So long time ago people thought that okay, atom is the tiniest particle. But later people started to cut that atom and see inside what is inside there. They saw the electron, proton, and neutron, right? So they call the subatomic particle. Yeah. So subatom. First of all, let's talk about the subatomic particle. So neutron, proton, and electron. So these three things are called subatomic particles, meaning that atom is made up of three tiny particles. They are called the neutron, proton, electron, and they are called subatomic particle, right? Subatomic particle. So now, what is the charges? So these electrons, you see here, electrons. So we write the minus here with the electron. Minus is all minus. So these have negative charges. So the electron has negative charges. All right. So electron. So charges in this subatomic particle. So electron has -1 charge. -1. So -1 charge. Electron has -1 charge. Yeah. So electron has -1 charge. And then this proton, where I wrote the proton has +1 charge. Proton has +1 charge. +1 charge. +1 charge. So you will see the homework in homework, this kind of thing, yeah. So and then in neutron. So neutron is right here. There is no charge. There is nothing, either plus nor minus. Neutron has 0 charge, no charge or 0 charge. So electron has -1 charge, proton has +1 charge, and neutron has 0 charge, no charge. Yeah. So the atom looks like this. We'll talk in future. So if you are drawing the atom like this, in this first orbit you can put only 2 electrons. But we'll talk in future. Yeah. In the first orbit, how many electrons we can put? 2. In the second, you can put 8 maximum. But it's not always there is 8 possible. But in the first orbit, this is called the first orbit. In first orbit, we can put 2 electrons. We cannot put more than 2 electrons. Either we can put 1 electron or maximum 2 electrons. Yeah. And in the second one, we can put 1, 2, 3, 4, 5, 6, 7, 8. So in second orbit, we can put 8 electrons, something like this. So if you the first orbit, we can put 2 electrons. In the second orbit, we can put maximum 8 electrons. So there are many electrons in the atom. So if we are started to put the electron, we put like this. In the first orbit, we always put 2 electrons. Yes. So now, how big? What is the size of this nucleus and the size of the atom? Suppose you take the atom of the, let's say, atom of iron, and there is a nucleus here, and this whole is the atom. So this is the nucleus of the atom, right? So how big is this one? So the people have given the idea that, so you take a soccer field, a big soccer field. So if the atom is the soccer field, so atom is the soccer field. So soccer field, right? Soccer field. This nucleus is the soccer ball. So that is the comparison they make. How small is that nucleus? So think about this big soccer field, right? And you have a soccer ball. So put that soccer ball at the center of that playground, and that soccer ball is the size of the nucleus, and that soccer field is the atom. So the nucleus is really tiny. The nucleus is very small compared to the size of the atom. Make sense? Good. So I did those notes there. Like this one. And how about the mass? So let's compare the mass of this proton. So the mass of the proton. So let's talk about, this is neutron, this is proton, this is electron. We have 3 particles, right? We have these 3 particles. How about the mass? So we just talk about the size. Now let's talk about the mass. So there are 2 ways of giving the mass of these particles, atoms or electrons. So I am in the slide 3 today. So I'm talking about the composition of atom and the mass. Neutron has 1.009 atomic unit mass, so they got U. So proton has 1.006 atomic unit mass. An electron has 0.00305 atomic unit mass. You see that? So among these three, neutron, proton, electron, neutron is the heaviest particle. So what is atomic unit? So we'll talk about the atomic unit later. So it is a kind of the unit of the mass that is used in the atomic scale. So if you are talking about the mass of the very, very tiny particle, we talk about, okay, it's the atomic mass unit. But if we are talking about the bigger, we are talking about the gram, right? If we are talking even bigger, we are talking about the kilogram, right? But if we are talking about big aeroplanes or ships, we are talking about the how many tons, right? So something like that. So that's the unit. So we go to the atomic or subatomic particle level, we give the atomic mass unit. How heavy is a neutron? 1.009 atomic unit. How heavy is a proton? 1.007 atomic mass unit. How heavy is the electron? It's really small, 0.0005 atomic unit, right? Now, if you divide this number by this number, you will get a 1834. 1834. So you will get 1834, 1835, or 1840. Yeah. So it's a kind of approximate number. So if you divide this number by this number, you will get something like this, 1834. So proton or neutron is 1834 times heavier than electron. Make sense? Yeah. So if you think that, okay, electron is 1 kilogram, neutron is 1834 kilogram, almost 2000 times heavier than electron. So electron has pretty much no mass, right? So you can say electron is kind of the, it has a mass. We cannot say massless particle. Electron has mass, but it's really small. Yeah. But neutron and proton are heavy. So pretty much, if you are measuring the mass of an atom, you are measuring the mass of this proton and neutron. Electron pretty much don't have mass. Yeah. I mean, they have mass. We cannot say electron don't have mass. But so if you are looking at the light is made of a tiny particle called photon. They call photon don't have mass, but electron has mass. Yeah. So electrons are not massless particles. They have mass, but they are really light. Very small. Very small mass compared to a neutron and proton. So how heavy is the neutron and proton compared to electron? 1834 times. So if electron mass is 1 kilogram, one electron mass is 1 kilogram, neutron and proton is 1834 kilograms. Yeah. So what is this atomic mass unit? What is this UU? I will talk about this later. Now, so if you want to express this mass in terms of the kilogram, so neutron is like this, mass of proton. So this is mass of proton, MP, mass of proton. Mass of proton is 1.6726219 10 to the power minus 27 kilogram. Really small. Mass of the proton and mass of the neutron is really small. This is in terms of kilogram. This is in terms of atomic mass unit. This is in terms of kilogram. So 1.6726219 10 to the power minus 27 kilogram is the mass of the proton. Yeah. How about the mass of the electron? It's almost same. So this is 9.109337015 10 to the power minus 31 kilogram. 31. You see that? Minus 27 is a big number, right? Minus 27 is a big number, right? But minus 31 is really small, right? Minus 31 is really small. So since there is minus 31 here, so if you talk about the mass of neutron, proton, electron, these are the number. If you talk the mass of the proton, electron in terms of the kilogram, mass of the proton is minus 27 kilogram, 10 to the power minus 27 kilogram, but mass of the electron is minus 10 to the power minus 31 kilogram. Yeah. So if you divide this number by this number, just put this number in calculator and divide with this number, you will get 1834. Yeah. Make sense? So 1834 times heavier is the proton and neutron compared to the electron. Electron pretty much no mass. Very small. Yeah. we cannot say electron doesn't have mass. Electron has mass, but very small. Now we talk about already the charge, right? So now let's talk about the. I already talked about the charge. Charge in neutron. In EUTRO and neutron is 0. Charge in proton is +1. Electron is charge in electron is -1, right? +1. This is 0, +1, and -1. Now we talk about the atom. So if you start to look the tiny particle inside the atom, some have some particle called neutron have 0 charge, no charge. The proton has +1 charge and electron has -1 charge. So how about the atom as a whole? So let's talk about the atom as a whole. So there is a nucleus, proton, neutron. There are some electrons around this atom. So what is the charge in this whole atom, right? So charge in atom is 0. Charge in atom is 0, just like the Newton. So there is no charge in the atom. Why? Because like this. So let's say this is a nucleus, and there are proton. Let's say proton and some neutron there. So like this. So this has minus. This has minus. So how many minus there? -1, -2. So in electron there are -2, right? So each electron has -1 charge. If there are 2 electrons, how many negative charge there? There are 2, right? 2 negative charge. So number of electron here and number of proton here are exactly same in atom. Of any kind of the atom, number of proton and number of electron are equal in number. Yeah? Number of proton and number of electron are equal. So there are 2 electrons here, so there are 2 proton here. So +1, +1, so +2. So -2 + 2 is 0, right? Yeah? So electron has negative charge, proton has positive charge, and number of electron and number of proton are equal in number, right? They are equal in number. So there are equal positive charge and equal negative charge in atom, so they cancel each other, and the total charge or the net charge in atom is 0. Yeah? So they call the atoms are electrically neutral. So atom doesn't have any charge. So take a tiny particle in the atom in because here these are the atoms. These are the atoms, right? So put this atom here and put two electrodes like the copper piece or iron piece, and connect this with the battery, and look whether they move like this way or this way, plus minus. They don't move. These atoms neither move toward a positive electrode, neither they move toward the negative electrode. So atom have no charge. Yeah, make sense? So why atom are electrically neutral or atom have no charge? Because in an atom there are proton at the nucleus, there are electron in the orbit, right? And the number of electron and number of proton are equal, and the electron has negative charge, proton has positive charge. So positive charge of the proton is cancelled by the negative charge of the electron. So the net charge in an atom is 0. Okay? So there is no charge in an atom. So how do we know that atom has no charge? How do we know that whether atom has charge or no charge? I just explain it like this. So take a beaker here, put one iron or copper piece here, and then connect this with the battery. So let's say you connect this with the positive pole of the battery here, so battery, and then negative, this is the negative pole of the battery. You just connect it like, and then you put some gold particles or gold atoms here. They are atoms in water. So there is water, and you put some gold, and you apply the voltage with the battery, and you look whether these particles are moving this way or this way. And when you look, they are neither moving toward positive nor moving toward negative, meaning that they are neutral. Yeah, if they were a positive here, they would move toward the negative. If they were negative here, they would move toward the positive, right? Since these particles are moving neither toward positive nor toward negative, these atoms are electrically neutral. They have no charge. Why they have no charge? Because the negative charge and positive charge cancel in an atom. The number of positive charge and negative charge are equal, so the net atom has a net 0 charge. Make sense? It's very important. All right, good. So I already wrote this in the slide number 4 there. Now, good. So we talked about the atomic number. So what is atomic number? Atomic number. So this is the identity of the element. Atomic number is the identity of element. It's just like your name. Yeah, atomic number is the identity of the element. So, so number of protons, number of proton, PROTON, proton is always equals to number of electron. And this is called atomic number. This is called atomic number. So what is atomic number? Atomic number is number of proton or and number of electron in an atom are equal, and that number is called atomic number. Make sense? So now let's look at the periodic table. So if you look at the periodic table, look the hydrogen, the first element, right? First element is the hydrogen. Look at periodic table here. I have put the another periodic table here also. So the first element here is the hydrogen. Yeah. So hydrogen. You will see 1 here. So 1 here. So this is the atomic number. And also you will see 1 here. I'll talk later about. We talked in last class also, but we will talk later. So this smaller number here is, if you look at the periodic table, the smaller number here is called the atomic number. Yeah. So how many proton hydrogen has? Number of proton the hydrogen has is 1. Make sense? Good. And how many electron the hydrogen has? Number of electrons. Same. Number of proton and number of electron are same. So this is the atomic number. Atomic number. So where is the proton? At the nucleus. If you draw the structure of the atom, at the center is the proton. Outside in the orbit is the electron, right? So this gives the atomic number, NUMBER number. So what is the atomic number? This is the number of proton is equal to number of electrons. So this hydrogen atom has 1 proton and 1 electron. Yeah. So let's talk about the lithium. So hydrogen, helium, lithium. This is the number 3. This is a very important element. All the batteries in the calculator or the computer are made up of the lithium. So if you look at the lithium ion battery, so they all are made of this element. Yeah. So lithium. So this is kind of the game changer for the human society, right? So lithium. If there is no place in the modern day where there is no lithium. Yeah. So this is in the battery. So this is a lithium. So if you look at the periodic table, there is a number 3 here, and maybe there is a number 7 here. Yeah. So look at the periodic table. So lithium. So sometimes they write in some periodic table they write the opposite way. So sometimes they write like this. So they write 7 here, they write 3 here. Sometimes they write 3 here, they write 7 here. So I'm just looking the smaller number. We just look the smaller number, yeah. So this smaller number 3 is the atomic number of the lithium, meaning that there are 3 proton in the lithium atom and there are 3 electrons. Make sense? So if I have to draw the lithium atom here, like in the structure, so this is a nucleus. So I have 3 proton here. So 3 proton, because this is 3, right? Number of proton and number of electrons same. So there are 3 proton. So plus, plus, plus. So there are 3 proton. And how many electron I have? Number of electron is also same. So I already told you, you can put 2 electron in the first orbit. So I put 2 electron in the first orbit. So this is minus 2 minus is there, and I put for another electron here. So I have 3 electrons. 1, 2, these 3 electrons, and these are 3 protons. So that tells this. Make sense? Clear? So 3 proton here at the center, and the 3 electron out. In the first orbit you can put 2, and in the second orbit whatever you are left with, you just fill it there. Yeah. So now if I have to put the beryllium, so look at periodic table. Beryllium is a third box in the left side. So here is a beryllium, and here is a 4, and here is a, I think it's a 10, right? 9.01. So if I round it, it's a 9. Yeah, so 9.01 is 9. So how does the atom of the beryllium look like? So make the center here, and then start to put the orbit around. So this is the nucleus. So how many? This is small number. Small number is the atomic number here. Yeah. So 4. There are 4 protons. 1, 2, 3, 4. So no, 940. So this is plus 4 proton here, and in the first orbit I'm going to put 2 electron here, minus, and I have out of 4, so I left with the 2 there, so I put 2 here, somewhere. You can put anywhere, yeah, in the orbit. Okay? So this is the beryllium atom. So number of electron and number of proton are equal, and they are called the atomic number. Now that's atomic number, and this number is an atomic mass. So this big number here is a they call mass number, a kind of atomic mass. Yeah. So how heavy is that? So so let's talk about this mass number here, atomic number. I'm just done with the atomic number. Now the mass number, MASS mass, NUMBR number. So this is the bigger number is the mass number. So the mass number is number of proton plus number of neutrons. So number of mass number is in atom, in the nucleus there are some proton and there are some neutron, and if you sum the mass both the particles, that's the mass number. Yeah. So if you have to draw the how many I already put it here. Out of 9 I already put 4 here. So there are other 5. 1, 2, 3, 4, 5. So these are the neutrons. So these black dots I make is a neutron, and these plus are protons. So I have total 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. Make sense? So this is called the mass number. So first of all, look here. What is here? 4. So make 4 positive there. And what is here? It's 9. So increase the number to 9. Yeah. So 9. So this one is a proton that has plus charge and is at the center. And this 9 is proton plus neutron. So if you subtract from big number to small number, you get the neutron number. Yeah. Right? Good. So total here is 1, 2, 3, 4, 5, 6, 7, 8, 9. If you subtract 1, 2, 3, 4, you will get 1, 2, 3, 4, 5. Okay? So that's a mass number is neutron plus number of proton. Atomic number is just the electron. So still we have time. So sometime you will see 9.002 here. So don't worry about that at this point. Yeah, this 0.002. So these are the atomic mass, and this is kind of the average. We'll talk later. Just if you see the number 9.002, just round it to the total number, the whole number. Yeah. If 8.99, round that to the 9. Yeah, so that you can find the number of neutron and number of proton easily. Very important. Yeah, this will be in test. So what is important? Because there are too many things in the book, so we cannot study everything. So we must understand those things which we must understand for the course. Yeah. So I will put something like this, and I ask you find the atomic number of electron, number of proton, number of neutron. So I will give like this. So I will give like this. So this is a X. So this is 8, and this is 18. So I will ask you, what is this element X? Yeah. So how many proton are here? Proton are 8. So go to the periodic table, and where there is a 8, just that is that element. Yeah. So go to the periodic table, and what is in the number 8? Number 8 is oxygen. Yeah. So this is here. So this is the identity of the element. So look the periodic table. Number 8 is oxygen. Make sense? And then how many proton are there? 8 proton. How many electron are with oxygen? 8 electrons. How many neutron are there? 18 minus 10 neutron. Yeah. So this minus this gives number of neutron. This 8 gives number of proton and number of electron. Make sense? Good. So we have 5-minute time, so we just finish it. Yeah. Now So mass number, atomic number, and elemental symbol. We finished that one. So atomic mass unit. So what is atomic mass unit? Atomic mass unit. So if you look at the nature, there are three kinds of carbon. One is like this, 6, 12. There are another carbon. This is 6, 13. There is another carbon. This is 6, 14. So in nature, there are three kinds of carbon. So I go to the environment and I collect some carbon and I start to analyze, right? And I found that, okay, all carbon is same. This carbon has 6 proton, 6 electron. This carbon has 6 proton, 6 electron. This carbon has 6 proton and 6 electron, right? But this carbon has 12 minus 6, 6 neutron. This carbon has 6 neutron. This has 13 minus 6 is 7. This carbon has 7 neutron. And this carbon has 14 minus 6, 8, 14 minus 6, 8 neutron. So there are, even though that is the same element, it has kind of the twins. Twins are triplets. Yeah? So this is a lot. So if you look in the nature, this is 99%. This is about 0.99%. And this is 0.001%. 0.001%. This is very, very tiny amount we can find in nature. And this is about 1%. But this is a lot, 90. Pretty much everything is a carbon we found in nature is this kind of carbon. That has 6 proton, 6 electron, and 6 neutron. Right? Make sense? Now, how did I get this 6 number? I subtract from this to this, and I get 6 there. So 6 neutron. Now, the scientists take this as a 12. So what is the mass number here? 12, right? 12. So scientists think that. So C 12. So they take this element and they give, okay, the mass of this guy is 12. Yeah? So they develop their own unit. How did they develop? They just think, okay, I get a C612, that atom, and I give the mass of this atom is 12. Make sense? 12. So the scientists give the mass of this guy is a 12 atomic mass unit. 12 atomic mass unit. Why? Because there are 12, 6 proton and 6 neutron, 12 mass number, right? So how much is the 1 atomic mass unit then? If this is a 12 atomic mass unit, if you divide this by 12, then that is 1 atomic mass unit, right? 1 atomic. How much is the 1 atomic mass unit? Take the carbon 12 isotope and measure the mass of that one and divide that by 12. And whatever the number comes, that is the 1 atomic mass unit. Make sense? So they divide that way. So they took the one, they go to the nature and they find this guy. And they measure the mass imbalance, I don't know how they measure, and they divide the mass of that guy by 12. And they say that, okay, that's the 1 atomic mass unit. Yeah? So it's just like, okay, so they go to the environment, and this is a carbon 12, right? And then so however they measure this mass of this guy, they divide it by 12, and then they got whatever the number that they call is a 1 atomic mass unit. Make sense? That's where that 1 atomic mass unit comes. Yeah? Good. So I think we studied a lot today. So we'll do some problem in next class about this one and isotope, and then we'll continue. Yeah. All right. Thank you, everyone. I'm going to stop it.